Welcome back to another video. This one is on vectors. It's our introduction to vectors. So let's get started. Okay, so far we've been talking about quantities such as speed, velocity, acceleration, distance, displacement, and position. Some of those are scalar quantities, ones where there are only a magnitude, and those would be position, speed, time, mass, temperature. And the others are vector quantities. Those are ones where direction matters. And those are like displacement, velocity, acceleration. If you've been putting a minus sign in front of it, it's probably a vector. The minus sign is a direction indicator. So now we're going to learn how to deal with them a little bit more formally and eventually get to the place where we can use them to help us solve problems that occur in 2 dimensions and maybe a little bit in 3 dimensions as well. Okay, so we have some notation for vectors so that we know we're talking about a vector and not just a scalar quantity. In text, printed text, we'll often see vectors notated as a bold uppercase letter. When I'm handwriting it, I will usually draw an uppercase letter with an arrow over it, and that arrow signifies the vector. The symbol for a vector is an arrow, signifying both the amount and the direction of the vector. And we have some anatomy for our vectors. The blunt end is called the tail, and the pointy end is called the head, or the tip sometimes. Okay, now vectors have direction. We need to know how to tell people what the direction is. We are going to use the math convention of where 0 degrees lies along the positive x-axis, 90 degrees is along the positive y-axis, 180 degrees is along the negative x-axis, and 270 degrees is along the negative y-axis. Or another way to look at it is our angles increase as we go counterclockwise from the positive x-axis. And the vector on the display here is called vector A. It has an angle of theta, and that angle is made between the vector and the x-axis. So here's your multiple choice question. Go ahead and take a Welcome back. Now we're going to talk about how we determine what the angle of our vector is. There are 2 methods that we use, 2 designations that we use for determining angles or for reporting out the angles. Most often we are going to use the standard polar angle that you've learned in math. And to get started, in quadrant 1, in the first quadrant where the x-coordinate and the y-coordinate are both positive, the angle for the vector would be between 0 and 90 degrees. And then in the second quadrant, our angle is going to be between 90 degrees and 180 degrees. And in this quadrant, we know that our x-coordinate is negative and our y-coordinate is positive. Third quadrant, no surprise here, I think, we're between 180 degrees and 270 degrees. And in this quadrant, both our x and y coordinates are negative. And then the final quadrant is the fourth quadrant. And that's where the angles are between 270 degrees and 360 degrees. And in this quadrant, the x-coordinate is positive and the y-coordinate is negative. Just to review, I'm sure you all knew that. Now I'm going to describe another way that we describe direction, and that's using the compass. So on a map, this would be the east direction, the positive x direction. The positive y would be north. The negative x would be west, and the negative y would be south. In the first quadrant, I'm just going to draw an angle here, or a vector here, and it has an angle of theta. And let's say that theta equals 30 degrees, and that's measured counterclockwise from the x-axis. Okay, perfectly good description would be 30 degrees. But there's also, when we're talking about compass direction, we would say that this vector is making an angle of 30 degrees north of the east direction. And that would represent that angle. We're going north in the direction of north from the east. Well, another perfectly good way of describing this angle would be that we are traveling 60 degrees in the direction east of north. Vector B here, what angle would that have? I'm going to draw a rough coordinate axis on here. So I know that this is 180 degrees and this is 270 degrees. So our angle lies somewhere between 180 and 270 degrees. And the way that I would write it is theta is less than 270 degrees and greater than 180 degrees. So how would we determine the exact angle of this vector? Just drawn on a piece of paper. Do you remember a tool called the protractor? Well, we would use a protractor to measure this angle, to measure the exact angle. That's really the only way we have of measuring that angle unless we know a little bit more information. Okay, the best way to determine magnitude or size of a vector is to measure the length. The length of the arrow represents the magnitude or the amount or size of the vector. And when we draw vectors on paper, the length of the vector is proportional to the magnitude or size of the quantity it represents. Now, here's a sample problem. I have three vectors. I have vector A, vector B, and vector C. Vector A is representing displacement of 3 miles to the north. And I mentioned scale. So what I have here, and this isn't a very convenient scale, I apologize for that. We have 3 miles being represented by 4 ticks. Okay, so our scale here would be 1 block is equal to 4/3 of a mile. Not very convenient. Well, let's move on. Let's look at vector B. We have 1, 2, 3, 4, 5, 6, 7, 8 blocks. Well, vector A had a length of 4 blocks. Vector B has a length of 8 blocks. If vector A was 3 miles in length, vector B must be 6 miles. And the direction, remember, when we talk about vectors, we also have to give a direction. So this would be 6 miles east. Next, vector C. This is a little bit more difficult. We really don't know what that direction is. I guess we could figure it out using a little trigonometry. It is, let's see, it has a 1, 2, 3, 4, 5, 6, 7, 8, 9 across, and 1, 2, 3, 4, 5, 6, 7 up. Now, if we think about this, this is creates a right triangle, and it has one side is 9 and the other side is 7. So what's the length of the hypotenuse of the triangle? We would say that the magnitude of C, and the symbol for magnitude is the absolute value sign, is equal to 9 squared plus 7 squared. That's Pythagorean theorem. Side A squared plus side B squared, take the root, and that would give us the magnitude or the length of our vector. And I'm not going to calculate that out. I'm going to leave that up to you. Okay, equal vectors. Now this is important. A vector is equal to another vector if they have the same direction and length. It really doesn't matter where they are in space as long as they are pointing in the same direction and they have the same length and also representing the same units. And so now I'm going to draw a whole bunch of equal vectors. Now I'm going to draw a whole bunch more. Now if you notice, they're all pointing in the same direction and they all have the same length. That's why they're equal. Inverse or negative vectors. They have the same length, but they point in the opposite direction. Sometimes we would say that they're 180 degrees away from the other vector. Okay, so vector A is pointing off up and to the right, and the inverse or negative A would have the same length but the opposite direction. Sometimes we call this anti-parallel. Now here's your free response question. Vector A has a magnitude of 5 meters per second. Vector B has a magnitude of 3 meters per second. What is the largest magnitude the sum of the two vectors could have? What is the smallest magnitude the sum of the two vectors could have? Good luck. See you in class.